So hi everybody, I'm Francesc Campoy, and as they said during the beginning of the talk, the beginning of the conference, they said I'm Francesc Flores. No, I'm Francesc Campoy. Campoy is not a middle name, and I'm a developer advocate for Google, not Alphabet. I don't know why they wrote Alphabet, but there's no Alphabet cloud platform, at least for now. So what I'm going to be talking about today is I'm going to be talking about Go tooling, and there's a talk that I gave at GoLand UK, which is a conference in London. Last year about program analysis in Go. And I got into a lot of detail on all the theoretical part of it, on the difference between dynamic analysis and static analysis, and then all the different examples of those tools that we had in the environment. And then I decided that this time I could do completely the opposite, ignore the theory, and just write code, and show you all the things that you can do with Go. A little bit of myself, I'm a developer advocate for the Go team and the Google Cloud Platform, and I'm on Twitter. If you can see that, that's my first name, and I'm also on GitHub, so you can send messages or bugs or pull requests or whatever you feel like saying. Cool, so on the agenda there's basically three things. First, I would like to know a little bit about yourselves, even those hiding on the left side of the room. So, how many of you have written Go before? Okay, how many of you have never written a single line of Go? Cool, that's a surprising amount of people. I'm not going to be showing very complicated Go stuff. We're going to write two things. One is hello world, and the other one is a web server. So it's pretty simple. Don't get too confused. But if there's anything that is not clear, just ask questions. The length of the talk completely depends on the level of caffeine, which means that I'm not really sure how long it's going to run. It should run around 40 to 45 minutes. But if we have more time, I have extra material, and if we don't have time enough, we can chat about more things if you're curious about later. But if there's anything that is not clear, or any questions you might have, just feel free to raise your hand and ask me questions. I will just repeat them. Okay, so demo time. So, I'm gonna hide that thing for now. I'm gonna start with a completely empty directory. There's nothing there. You can see it, cool. And the important thing is that in Go, everything that you write, all the code that you write, is in your Go path environment, a variable. And Go path, in my case, my Go path is my home, which sounds very deep, but it's just basically everything that I write in Go will be somewhere inside of my home. That will generate three directories. It will generate source, that contains all the code inside. And there's GitHub and Google, because I have internal stuff, and Bitbucket, and yeah, a bunch of different things. And if you look inside of them, you're going to find basically all the GitHub code that I might have ever used. It will be there. Then there's also PKG, which is where I compile stuff. And you're gonna see that there's a couple different platforms. So there's Go Mobile, and then there's Darwin, which is the one I'm using, and also Darwin for App Engine, which is when I'm writing code for App Engine. And finally, we also have the binary that contains all the binaries. So when I compile some Go code and generate a binary, I'll just put it there. And that is my environment. That's everything we need to know for now. Okay, so I'm gonna start by writing, actually, open. I'm gonna do it as simple as I can. It's actually very hard for me to use Go without any tooling. So I'm gonna do text edit. So you can see how it feels to actually write Go. So I'm gonna write a hello world. So package main, function main.
It's a little cut off again.
Oh, it's a little bit cut off. Let me go down a little bit. Okay. Hello. Go to. And that is my Go program. And I have to do import font. We pronounce it font, short for format. If not, don't autocorrect me. Okay, and that is my Go program. And that is a hello world. And it's really ugly. But let's try to run it. How do you run it in Go? Very easy. Go run main.go. Oh yeah, that's a really bad idea. Okay. Text edit actually adds magic things in the middle. So I'm just gonna do package main, import font main, println, hello Chicago. Cool. Go run main.go. Hello Chicago. Cool. We have our hello world. Very simple. Now, if you've written any Go code, you will realize that this code doesn't look like code that you normally see. The formatting of the code is actually not correct. And that's actually I'm gonna talk about another tool that we have, which is static analysis tool. But it's the static analysis tool that everybody in the Go community uses all the time, Go Font. And Go Font, what it does, it formats your code. So it's basically like a pre-printer. And it's a very opinionated pre-printer. You cannot tune it to look like you want your code to look. The idea is that the whole community agrees on how the code looks, which means that all the code in the Go community looks exactly the same. Nobody loves that specific format, but everybody loves that there's one specific format. So how do I do that? Well, I can do Go Font main.go, and that will reformat it. Didn't do much, really. It just added those 2 lines because they need to be there. But the cool thing is that this actually you can also do -w to rewrite. And now my main.go looks like it should. And this is something that you're gonna see every single time that I'm gonna use my editor. Every single time that I save, I'm gonna be running that. So let's use my editor. Where did it go? There you go. So I'm gonna be using VS Code, which is actually pretty awesome. Okay, so that is my program. If I add a line, it will remove it. Cool, so that's the first tool, Go Font, and the goal to Go Run. What happens in Go if you don't have this? Well, it will not compile. If you try to run this directly, it will just say, I don't know what font is, you need to import it. And if you import something and you don't use it, Go will complain about the fact that you're importing something and you're not using it. And this is something that a lot of people at the beginning complain about because they find it pretty annoying. The important thing to know is that, again, there's another tool that will do that for you. And this tool is called Go Imports. And Go Imports, what it does is, if you're missing any import statement, it will add it for you. So I just save there. It just adds it. And if you are using another one, hello on the logs, we will add it too. And then when I remove it, it will remove it again. So you can't forget about all that import statement. All those things are automatically done. What is cool is that this doesn't only work on the standard library. That is cute, but the cool thing is that I can use other things. Like for instance, there's a package called Gorilla, which is a web toolkit. Imagine that I wanted to use new router. And I'm gonna add this too. Because if you declare a local variable and you don't use it, that is also a compilation error in Go. You see that? The way it works is that it went on my Go path, found all the code, found a package name with the name mux that has a function named newRouter, and gave me that one. So that's actually pretty powerful. It means that I can forget about import statements, which is really nice. Cool. So, more things that are cool about Go tooling. So I showed Go run main.go, and that is pretty nice. And it makes it look like Go is interpreted, which is completely false. Go is compiled, and it generates static binaries. So you can do Go build. And when you do Go build, now you have that file. And that file is just a binary that you can send around, and it will run on any macOS 64 bits. What if I wanted to build something that runs on, let's say, Docker? So I want to build a Linux binary. Well, it's actually very simple. Go OS Linux, go build, and done. Now I have a Linux binary, which is pretty powerful. The coolest part is go OS Windows, and on my Mac, I just generated demo.exe. And this works out of the box. Cross-compilation is a very powerful tool, and is one of the reasons Go is very popular when you're creating clients. When you need to distribute those clients, instead of distributing, imagine if it was a Python script, you need to make sure that the host that is going to run that Python script has the good version of Python and also the dependencies. When you're providing a binary, everything is already there. You just need to provide the good binary. There's one more option. Let me delete these demos, not that one. There's one more option, which is go install. And go install, what it does, it compiles it and it installs the binary on my bin. So now I can go find here, bin, demo. That's the same. And that's actually what you're gonna do most of the time. Go install, or even better, go get. Go get is the coolest one of all of them because it does a lot of things at the same time. So if we go to github.com, go on example, okay, I have something there. I'm gonna, to make sure that I'm not cheating, I'm gonna delete that directory. I don't have that code in my repository anymore. And now what I'm gonna do is I want to run the example hello world in that repo. So I can do go get github.com/golang/example/hello. Now that's going to GitHub, downloading the code, installing everything together, and putting the binary on go path bin hello. And that's actually pretty much what you end up doing most of the time. You write your code inside of your Go path, and then you go get to install, get the dependencies, etc. Any questions about this part so far? Okay. That is actually pretty simple. There's the basic steps. Now, what else can we do? Well, we can do go list. And go list is a very interesting tool because when you run it, it just says, this is the name of your package. Which is really boring, because I could do that with pwd, right? What is near here? Well, you can do things like, well, give me using this format, and then using this Go template. So I can use Go name. And the name is the name of this package. The name of the package is main, because it's the binary. But also, I can do doc, and that is documentation. I didn't write any documentation, so there's nothing in there. That is pretty sad. I will write some documentation. So I'm gonna say, package main says hi. Whoop. And now if we run it again, it says package main says hi. Cool. Not very useful, but you can do other things like give me all the import statements. And now this is pretty powerful because you can run this on whatever you want to run it. So I could run, there's a strings package in the standard library. What does string depend on? It depends on errors, IO, Unicode, and Unicode UTF-8. And if you want to be a little bit fancy, you can run functions inside of that parameter, of that template. So you can do things like this. And then also you can build tools on top of your Go programs that are very easy because the Go tools are already there. The Go list tool is already there for you. I showed that one of the ways of getting documentation for a package is doing Go list with the format .doc, which is one way, but it's definitely not the best one. The best one is to run Go doc. Go doc will give you documentation for the current package, but also you can do Go doc for strings, and it will give you documentation for all the functions in the strings package. I can do also, I want to know the documentation for the compare function on the strings package, and it will give you exactly the documentation. And that is cool, But very often, when we're reading documentation, a browser works better than the command line. So you can do start this on the port 6060. And what happens if I visit the port 6060 now? I get the Go homepage. And that is actually a locally run version of the Go homepage. The cool thing is that when I click on packages, I don't get only the standard library. I get all the packages on my computer. So I can go and look for the example hello that we had. That is a binary, so we don't have it. Let's go for strings. You're going to see this is a strings package that is inside of Kubernetes, whatever. The important thing is that all of a sudden you get all of these things for free. You get documentation, you get all the examples, and you can read it around. When you're writing code, this is actually what you want to be checking out. You want to make sure the documentation that you're generating, auto-generating, makes sense. Okay, so that is the end of the basic stuff. Now let's write a web server. So how do you write a web server? First thing is I'm going to handle all the requests that start with /, which is all the requests, with a handler that I will write in a minute. And listen and serve, 8080. And my handler is something that given a response writer and HTTP request. That's something, and just going to do hello Chicago. So that is my whole web server. That is a full web server. And I can demonstrate it works by doing go run main.go. And it doesn't work. What is going on? I think I know. Yes, so it's not working. And the worst part is that it's not working, but it's not telling me why, which is the awful part of it. If it fails, but it tells me it's because you don't have rights to bind on port 8080 or whatever. I'd be happy with that, but it's not saying anything. So in Go, there's no exceptions. We don't use exceptions at all. Instead, we have this concept of panic. And you don't panic, you only panic exceptionally. You should not be panicked all the time, right? So instead, what we use the concept of errors. And those errors are values returned by functions. But you need to remember to check them. Now, if you have an error, if you have a function that returns something and an error, you cannot omit the fact that that error has to be explicitly omitted. You have to say underscore to say, I don't care about this error. I'm not checking it, but I know I'm doing that. But in our case, the problem is that one of the functions is returning only one error. And we're not checking it. And there's two ways of finding this out. One is reading your code reviews, and all that stuff. The other one is tooling. And this talks about tooling. So there's actually one function, one tool called error check that does exactly that. And it tells me, oh yeah, HTTP listen and serve, that returns an error, and you're not checking it. So you should definitely be checking that error. Cool, so let's go back here. And we can see documentation for listen and serve. It says listen and serve that given an address and a handler, it returns an error. That error is not checked. So let's check that out. Whoop. Cool. So now everything that I'm doing is I'm actually checking for the error. In this case, you don't even need to check that error because this is a web server. If it stops serving, something went wrong for sure. So that error will never be nil. But let's write that code like that. Okay, so I'm gonna try again. Go run main.go. Oh, okay, so listen TCP 8080 failed because there's someone already listening on it. And it's because I was running that before. Cool. So I stopped the other server. Let's try again. And I get that annoying dialog. It's macOS way of saying the web server is working. So, localhost 8080 and hello Chicago. Cool, so now we have a web server that is actually running. Not only that, but this is a 75 megs. No, wait. No, 7 megs, that is much better. Yeah, that is much better. There is a 7 megs web server that you can just put on production and run it. Well, you should add probably SSL and stuff like that, but other than that, it already runs. It has everything it needs to run in production. So you don't need Nginx or anything extra to write Go web servers. Everything is in the standard library. Cool. So let's make it a little bit more interesting. And by a little bit more interesting, I mean worse. So what I'm going to do is, I'm going to check on the path of the request. I'm going to check if it's an email. And if the email ends with @golang.org, I will do something. Otherwise, I will do something else. So I'm going to say, okay, my path is path. And I'm going to do the worst thing you can do ever in life, which is import regular expressions. I'm going to say, I must compile this thing, and it's something golang.org. That is my regular expression. Okay, so match, find all strings of match on path. So I'm matching that. If match is not nil, then it means that I actually found something inside, and I'm actually going to extract that. So I'm going to print fprintln hello gopher, and I'm going to give the name match of 1, which is actually the thing inside of the regular expression, so whatever, @golang.org. And then I'm going to return. Otherwise, I'm just going to say, hello, dear path. Why not? And that doesn't compile. That is sad. Oh, how many do I want to match? All of them. Why not? r.path is not r.url.path. And that fprintl and fprintln. Cool. Does that compile? That doesn't compile because I'm actually forgetting the fact fprintln receives a writer. So where are you writing? And now all the red things are gone. The compiler is happy, but that's not enough. There's actually another tool that is running, which is called govet. And govet, what it's doing is a static analysis of your Go code that works really fast, so you can do it on save, basically. And it's going to tell you things that are correct from the point of view of the compiler, but probably you're wrong. And with that probably, it means that it might have false positives. It happens sometimes. In my personal code, I've never seen it. There's some weird cases where sometimes you might want to add a little comment. So it's like, I know what you're doing, let me do this. Okay, so what this is saying, it's saying you're calling println, and then you're passing a formatting directive. Oh, yeah, if you're doing this, that's not println, that's printf. So, printf. And it doesn't complain anymore. Printf, and it doesn't complain anymore. Cool. So let's try again. Go run main.go. It works. And if I do foo, it says, hello dear foo. It's a beautiful name. But if I say foo golang.org, oh, something went wrong. Something went really wrong. That is a panic. That is what happens when you write bad code. There's no exceptions, but sometimes you write things that are just wrong, and then a panic occurs. When a panic occurs in a web server, the request fails, but the program doesn't crash, which is nice. Cool. So, how do we fix this? Let's do something that a lot of people think it's impossible to do with Go. I'm going to set a breakpoint, and I'm going to debug it. Now I'm gonna refresh. Oh, it crashed. What did it crash? Oh, I think that it did something. Oh, yeah, okay. Let me stop it. Okay, so I started. Now my server is running. I test, and I can refresh, and I get the breakpoint right there. So the support for breakpoints, the support for debuggers in Go, it's actually, compared to last year, it's actually pretty good right now. Even on Mac OS and OS X is not the best place for debugging, really. But it works. And okay, so let's see what's going on. The next step, okay, so match is not new. But what is match? Well, match is a slice with one element that has two elements. And I'm actually trying to get the second element directly. So that's actually wrong. What I wanted to do was get the second element of the first element. That's on me. Okay, let's try that again. Gonna run. Yes. And refresh. And now it says, hello, Gopher foo. It says Gopher, which is good, but I actually just wanted this. So, you know what? I'm just gonna drop the first character. Because I know the path only always starts with a slash, so I'm just gonna say, drop that, and keep on going with the rest. Yes. Cool. Hello, Gopher foo. Hello, Gopher Francesc. Hello, dear Francesc at gmail.org. So everything is working. Cool. Ship it. No. There's a lot of things that are very wrong with this. So, we're gonna do something that is better than just testing your code in production, which is writing unit tests. And this is gonna be the first, actually probably the second dynamic analysis tool that we're gonna use. The first one was the debugger. So, I'm lazy, so I'm gonna do a copy paste of my test right here. Actually, not even that one. This one here, web test. There you go. Okay, so that is my test. To say that something is a test file, you need to create a file that finishes with _test.go. And now that means that when you do go build, go install, go get, those files will be ignored. They will be taken into account only when you do go test. Okay, so I pasted that. The cool thing about go imports is now I can do save, and all the imports that were missing appear automatically because they go imports know where they are. Cool. Now I can do go test, and my test failed because it says expected hello Gopher Campoy, and it got. I did not say what it got. That is. Let's. Gopher Campoy, and it got. Hello Gopher Campoy. That is not very useful. I'm just going to change it by strings contains. And it contains hello Campoy. Let's see. Go test. That doesn't compile. That is even worse. Okay. Let's try now. That is a sad thing. I'm not able to pass my own test. Just say that. Go test. No. Body.string. Am I testing the good thing? Yeah, I'm testing the good thing. Okay, so I'm gonna make my test much simpler. Go test. No, what? Oh, does it work the other way? No, it works this way. My testing is broken. I don't know why. That is, hello, Gopher. Okay, so what I'm gonna do is I'm just gonna go back. think that might be the problem. I don't know if that's a problem. Go test. That is very sad. I don't know what's going on. Okay, so I'm gonna fix my test by doing something that you should never do, which is, yeah, story works. Cool. Go test. Yay, my test passes. Why? Because I'm not checking anything. I'm just checking I'm getting 200, good enough. Cool. So now that is my way of testing stuff. Don't do that at home. Actually write test at work. But we have a lot to see, so we keep on going. Okay, so now what I can do is I can run that test also from here. So I can do run, no, test. I want to run the test on this package, and it says, yeah, I run the test handler and it passed. Good. Now, even better, let's show both at the same time. That may be a little bit too much for you to read. Okay. Oh, doesn't make it smaller. Okay, so I can also run test and get the coverage. And I can see that my test is actually not complete. It's testing only one part, but it's never testing this side. So probably what I want to do is I want to say, you know what, I'm gonna add another test, test handler 2, that uses something that doesn't match. Let's try again. Test with coverage, and now it passes. Now we're actually testing the whole thing. We're not testing anything, but technically we're running all the length of code. So that is actually something that also comes with Go test. The coverage is automatically supported. Cool. So since everything is working, now the next step is let's run it. So what I'm going to do is I'm going to run main.go, main.go. Okay, now it's running. And that is not what it's supposed to be running. That is throwing not the good place. Okay. Tooling, demo. Okay. Okay, so I'm running my server, and at the same time, I'm gonna run this little tool, which is not really anything related really specifically to Go. But when it's going to say it's going to run during 5 seconds, it's going to do basically a load testing of my server. It's a very simple thing, but it's going to use Tango routines, and it's sending all of that at the same time. And once it's done, it says, cool, I was able to do 31,000 requests per second, which is actually pretty good, but maybe we can do better. So, cool. So we have this. How can we make it better? No clue. We need more stuff. We need more information, right? So what I'm going to do is I'm going to add instrumentation to my web server. And to do that, everything you need to do is you need to import net HTTP pprof. That is a big fail. Net HTTP pprof. Now, if I say this, it will disappear because Go import says you're not using it, so you don't need it. But I actually need it, so I'm gonna say, yeah, shut up. So that underscore is basically saying, I know that I'm not using it, but keep it there. I need it because it's gonna be doing things in the background. Okay, I run my backend again, and now if I go localhost 8080, that looks like it's working. Cool, but now there's this extra thing, which I can do debug pprof, and I get to this page. And this page contains all the information about my server, what is it doing and how is it doing it. So I can see that there's 4 Go routines, I can see what it's doing. There's not much going on, so I'm gonna send some traffic. Okay, now we have Tango routines actually working, and you can see that some of them are serving HTTP, some of them are waiting for connections to arrive, which kind of makes sense. We have our server running and waiting for the traffic. Cool. So the next step is, well, I want to know more about it. Actually, there's something that I forgot to mention, which I like a lot. You can also see the heap. And the heap has a huge amount of information, and you should not try to understand it. But at the end, it says how many garbage collections have been run. And also, it tells me the nanoseconds for every single pause in the last 256 pauses. So you can parse this to do extra monitoring. And that's actually something that people do very often. But I'm actually pretty lazy, so no, I don't want to write that to myself. Instead, what I'm going to do is I'm going to do GOTO pprof. I'm going to run it for 5 seconds. And I'm going to point it to debug pprof. What is that? I don't know how to read. pprof? GOTO profile. That is, sometimes I'm not able to read what I write. Cool, so that's going to be running during 5 seconds, and now I have pprof. And pprof is a very cool tool that a lot of people use. And when it's the first time that you see it, you do top, and there's nothing. It's like, what? And why is that there's nothing? Because I did the profile with no traffic. Big error. Okay, let's go work it again, and let's do it again. 5 seconds, now with traffic, and now, after 5 seconds, I'm gonna call this, because otherwise my computer gets tired, and I do top, and I'm still like, what? That is a lot of information and runtime and stuff like that, but not very useful to me. I want to understand what's actually going on. So you can do web, and it's gonna show you this cool graphic with all the things that are going on. And somewhere in there, you're gonna be able to find serve HTTP main.handler. That is actually the code we wrote. This little thing here. And you need to understand everything that is going on inside, so it's actually not that useful. It's kind of complicated to understand what's going on. So instead, what I'm gonna do is I'm gonna still run code. I'm gonna replace all of these with Go Torch. Actually, it's Go Torch during 5 seconds. And this is going to do exactly the same thing, but it's going to present the data in a very different way, in a way that I like much better, which is a flame graph. How many of you have seen flame graphs before? Cool. It's especially people that come from Ruby and Python are very used to it. People coming from C++ or Java, they're not that used to it. Okay, so I'm going to just open the torch. And this is why it's called a flame graph, because it looks like a flame. The colors are completely random, so it looks like a flame. That's why the colors are those colors. But the important thing is that basically you have for every width is actually the whole time that you've been executing that function. And the functions on top, stacking on top, are the functions that are called by the function below. So I can see that there's somewhere here, use sleep, buffer writer flush. That is read request, finish request, serve HTTP, okay, and main handler right here. And I don't know if you can really see that, but we can see that my code is not doing what it should be doing. What? Am I modifying the wrong file? Let me check. I think that I did something wrong at some point. Go run. That is totally not my code. Okay. Whoops. Where am I? Go tooling demo. Somehow I changed the code of my. That is not the code that is being executed. Main.go. Okay, we all agree that in here it says must compile, and then here it doesn't, right? Go to link demo. Go to link demo. Okay, so that normally should not change anything, but it did, cause magic. Cool. Okay, so I'm gonna run that again, and I'm gonna run my torch again, because then it will make more sense. Not open, but actually generate that torch. Go torch. Okay, and now I can open my torch. And go to main handler. And you can see now there's much more things. We have the find all strings of match that is taking a lot of time. Also, we have the mask compile that is taking a lot of time. And finally, we have somewhere in there the actual writing of stuff, the fprintf. It's being called right here. Cool. So something that you can do quite easily is, I'm going to start removing things. And one of the obvious things is that I don't need to compile that regular expression every single time. That's actually pretty dumb. So I'm going to move it out, and I'm going to say, just do it at once, and then the rest should work. Go run main.go, and you can run it again. We should see that on the net HTTP here, main handler, the compilation time is gone. So now that's something that we've won. How can we know that we actually did better now? Well, we can check go work again and see that before I think we had, actually before we had the maximum requests per second, because that was the fully optimized code, that's why. But we're going to 12,000 requests per second. Before, it was actually 30,000, that is the goal of the talk. But at the beginning, you get something like 10,000. So it's a little bit better. Now, the important thing about this is not good enough. Because basically, you're blindingly improving your code based on current traffic of the things. Instead, sometimes what you want to do is you want to write a benchmark. To write a benchmark in Go, it is as simple as copy-pasting. Benchmark is just a different kind of test. So it looks exactly like a test, but instead of having testing.t, it's a testing.b. And that has an n. That is the number of times that you have to run that test. So I'm just going to copy that, put it in my test, stop the worker because it's annoying my computer. And I'm just going to move it here. Benchmark handler, cool. So how do I test it? Go test that bench. And now I can see that I have how many nanoseconds per operation that it's taking. I can also say bench mem. Tell me how many allocations I'm actually doing per operation, which is a huge amount of allocations right there. So that's probably one of the ones we have. And also you can do CPU profile, prof.cpu. So now when they do this, it will generate a CPU profile. All right. I can open that CPU profile with go to pprof. So it generated a test binary, which is the one that you use to run pprof. And I can do prof CPU. And again, I can do web and see the whole thing. And that is one way of doing it, but I don't like this one. So instead, what I'm going to do is I'm going to do go torch, binary name is demo test, and binary input is prof CPU. Open torch. And that will open my handler with specifically what I'm actually debugging, what I'm actually verifying, and what I'm actually benchmarking. So there's a lot of things that you can see here. One of them is using regular expressions is a really bad idea. I'm actually spending most of my time backtracking on verifying is am I actually done. So the solution for this is actually very simple. Forget about regular expressions. Instead, just use, on my other code, I just check, does this string finish with @golang.org? And that's it. So before we do that, let me make sure. So we had the 39, almost 4,000 nanoseconds per operation. I'm just gonna change that code. So replace my handler with that. So now we're not using regular expressions. And just try it again. So let's test bench. And now we went from almost 4,000 to almost 2,000, and the allocations went down by a lot too. Again, you could open it, see what's going on, open your torch, and see that the next step is probably when you're doing, wait, where did it go? Okay, it is now so small that I cannot find it. There you go. So it's actually spending most of the time writing, which is basically what we want to do. The rest of the operation looks pretty nice. How do you make that better? Instead of writing like that, just write byte by byte if you want to. There's ways of reducing the allocations. I want to show, if you wanted to remove all the allocations, something that you can do, actually, is you can also do, go test, mem profile, prof.mem. And that will generate another profile, which is a memory profile. Again, I can do this. So, what? Okay, now everything is prof.mem. And I can do top, and that doesn't really help. But if I do list of my handler, ooh, that fell. Oh, that is sad. Normally, you should actually show the number of allocations that you have. Oh, I know. Alloc objects. So it will also track, no. Oh, that is actually here. Okay, go to pprof, demo test, problem mem, alloc objects. Alloc objects. I'm not able to write today. One second, I'm just gonna make it smaller so it actually works. Okay, that allocs needs to be removed. Oh, no, it's the other one that needs to be removed. That's where the flag goes. Alloc objects. Okay, and I can do list handler, and it will show where all the allocations are happening. So then you can follow inside and understand what's going on. You can also see the assembly on it and see where the allocation is actually happening. And it's actually calling fprintf directly. So that is the point where all the allocation is happening. How could you remove it using different kind of writers? But we're almost out of time. So let me see. We don't have time for the bonus part, which is sad because it's actually pretty cool. So all the things we saw the Go tool that has a huge amount of things. It has build, run, install, get, test, and tool, but also go funct, go vet, go doc, go list, go test, which are very useful, and you should be using them most of the time. And then a couple extra things, go imports, go linked, error check, go torch, that are things that are built on top of the Go ecosystem, but are not part of the Go tooling itself. And then Guru. Guru is actually, if you've ever used Go Oracle, Oracle was renamed for reasons to be called Guru. And basically it allows you to understand what's going on in your program, but in a static analysis way. So you can actually go to a function and say, show me the call stack, show me one call stack that gets here from main. And it will not run your code. it would just analyze the whole graph of codes to understand how you can get there. If you want to learn more, there's 2 talks that get more into detail on the theory. One is Profiling Optimizing Go by Prashant Varanasi. He's an engineer at Uber, and he gave a great talk. The videos are online. My slides are also online, and I will tweet them in like a second, so you can also find on Twitter. And then the other talk that I gave, Analyzing Go Programs, where I actually go over all the theory behind it and the tools, all the packages in the standard library that power these kind of libraries. And that's it. Thank you very much. And I don't know if we have time for questions, but otherwise you can find me outside. Thank you.